let's see the next question. During the compression of a spring, the net work done on the block is. So obviously during the compression of the spring, so assume that, so there is a spring over here, and again I'm just going to, you can say that, so keep a block over there. So you can say, so the kinetic energy of that block has been given to this spring, so that is nothing but it get converted into potential energy. So at the same time, in the equilibrium position, you can say that it has been compressed over here, so all the kinetic energy has been converted into potential energy for this particular case. So the potential energy which is trying to restore its original position, the energy in the spring and the weight of the block acting in the downward direction, both are equal and opposite. So the net that is a net work done on the block has to be 0. So your option C is correct over here. So let's say the next one, a constant power P is applied to a particle of mass m. The distance traveled by the particle when its velocity increases from v1 to v2. So I know that, so let's say power, we are saying that it is nothing but work done upon time, the rate at which we are doing the work. So again, work done, you can say force into displacement upon time. So further we can say that is a mass into acceleration into s upon time. So further even you can say that is a m. Again acceleration, we can say that, so this is your dv upon dt. So this is further we can say that, so this is your dv upon dt over here, and even I can say that, so let's say this is your ds upon dt for this particular case. So power is the rate at which we are doing the work. Again we can say that, so that is a mass into acceleration. Acceleration is dv by dt into ds by dt. So for this particular case, again this is, I can write it down, dv by ds into ds upon dt. So that is what we can write it down for this particular case. So this is what we can say now. So this is P, again m, again further obviously this dv by dt, that is a dv by ds, ds by dt, and this is ds by dt is v. So again this ds by dt is also v, so this is dv upon ds into v square. So I can say now, so further P is equals to mv square, P is equals to mv square dv upon ds. So P is equals to your mv square dv upon ds over here. So let's say again further what we can do for this particular case over here. So this is P upon m into ds, and this is v square dv. So taking obviously the integration on both the sides. So P by m, again we can say this is s, again this is a v cube upon 3. Again let's say the limits are from v1 to v2 for this particular case. So P by m s, again 1 by 3, again, so that is a v2 cube minus v1 cube over here. Now what we had to find over here, so that is, yes, so definitely we can say that is what we had to find for this particular case, the distance traveled. So distance traveled is s, so m upon 3p, and we can say then it is v2 cube minus your v1 cube over here. So this is what we can say, m upon 3p v2 cube, yeah, and again v1 cube over here. So this is what we can say, m upon 3p v2 cube minus v1 cube over here. So your option A is correct for this particular case.